Hello everyone. Today we are going to start our next unit, which is also having to do with energy, except specifically we're going to look at electrical energy in this unit. And we are going to start by looking at electric charge. So these are the notes for chapter 20, section 1. Our learning targets today are to be able to identify the parts of an atom, identify the charges associated with subatomic particles, examine the interactions between those charged particles. And our two essential questions we're going to look at: how do subatomic particles of an atom determine the charge of an atom, and how do charged particles interact? So, as always, we're going to start with a little bit of review because these are the concepts that we'll need to know in order to be successful in this unit. So, our first review is going to be to define force. Okay, so this is from way back in the fall. We haven't actually talked about it for a little bit. So remember, the definition of force is a push, a pull, or a twist. All right, one object is doing this to another object. And we separated forces into two types. We separated forces into contact forces and long-range forces. So an example of a contact force would be if you were to throw a ball. Other things that are contact forces are kicking a ball, friction, running, the contact between your feet and the pavement, getting hit by a pitch, that sort of thing. And a long-range force, our example that we're going to use today is gravity. But we have also talked about things like magnetism, right? You don't actually have to have the two magnets touch each other in order to have them react with each other. All right, so got those things in your mind? Okay, here we go. Question number 1, how do the subatomic particles of an atom determine the charge of the atom? So here, let's take a look. Here is a carbon atom. You can tell it's a carbon atom because in the nucleus there are 6 protons and 6 neutrons, But what we really care about in this unit is that the number of protons, 6, and the number of electrons, also 6, are equal to each other. Okay? So most atoms start out this way. And if you had some chemistry in junior high, you probably remember that. So let's go ahead. We're going to, up here at the top, say atoms. Whoops, that's not what I want. Atoms are naturally neutral. What does neutral mean? That the protons and the electrons are equal. What about those neutrons? Well, the neutrons help to give size to the atom, but they don't affect its charge. So we're not going to worry about the neutrons in these particular examples. Okay? All we're really concerned about are the protons and the electrons. Okay, so if atoms start out neutral, they have an equal number of protons and electrons, how do we end up with positively charged things and negatively charged things? Well, what I want you to do is use your imagination, okay? And I want you to imagine that this carbon atom here got really excited. Those electrons swirled around the outside faster and faster and faster and faster, and finally one of the electrons got so excited that it jumped off. All right, so instead of having 6 electrons on this carbon atom, now I only have 5. So this electron, we'll just make it this one right here, jumped right off that. Got so excited, we added so much energy to it that the electron jumped right off, and now we have, it's really not a carbon atom anymore, is it? But now this atom has 6 protons, but it only has 5 electrons. So because they're not balanced anymore, this carbon atom now has an overall positive charge. Does that make sense to you? It's just like math. If we were to take a positive 6 and add a negative 5, we'd end up with a positive 1. This atom has a positive charge. But the question that you're probably asking yourself right now, at least I hope you're asking yourself this question, is where did this electron go? Right? It didn't just disappear into the Never Never Land or something. It had to go somewhere. And the answer is that it jumped to the nearest atom that was close to it. Okay? So, give me a second here. We're going to draw another atom. So I'm going to have a proton and a neutron and 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 a proton and a neutron. 1, 2, 3, 4, 5. Okay, so I got another carbon atom here, which means that it has some electrons here. I didn't draw that very well, did I? It's okay. All right, so there's my happy neutral carbon atom, but this extra electron has to go somewhere, and so where it's going to go is right here to the nearest other atom that it can get to. So now this second carbon atom has 6 protons, but it has 7 electrons. And so it's going to give it an overall, negative charge. All right, so see how that happened? So I ended up with, one positively charged atom and one negatively charged atom. Do you think they also always have to happen in pairs? Yeah, they usually do. They usually happen in pairs. So let's put that up here as well. So charged atoms almost always, you can fiddle with this a little bit, but almost always occur in pairs. Right? So if you've got a positive one, then somewhere around you've got a negative one, right? Because that electron just doesn't go out for coffee or something. It has to go someplace. Okay? So I started out with a neutral. Actually, I started out with 2 neutral atoms. This electron got so excited that it jumped over to this atom, and now I have a positively charged atom and a negatively charged atom. All right? So let's summarize. An atom with an equal number of protons and electrons is, good for you, neutral, which means it has no charge. Those protons and electrons cancel each other out. You end up with a 0 if you're going to add them mathematically. An atom with more protons than electrons is going to have a positive charge. And an atom with more electrons than protons is going to have a negative charge. All right? So take a second, look that over again, make sure you feel comfortable with that, then turn the recording off and do your turn. You're going to choose for each of these pictures, is it positive, is it negative, or is it neutral? Okay, you just need to circle your choice. So I'll be right back. All right, let's keep going. Here's essential question number 2. How do charged particles interact with each other? So what happens here is that every charged particle creates a charged field around it. Let's change colors. We're starting kind of a new idea. Okay? So if I have a positive atom, right, this is my little carbon in here or something, it's got more protons than electrons, it's going to create a positively charged field. So this whole field is going to be positively charged. If I have a negative atom, it's going to give me a negatively charged field all the way around it. Okay? So every charged particle creates a charged field that surrounds it with the same charge as the particle. All right? And charged particles interact with each other. They exert forces on each other. And these charged particles are different. These forces are different than gravitational forces. Gravity, remember, gravity is only going to attract. It's only going to pull toward you. But these forces can attract or repel other objects. Repel means to push away, okay? And here's the pattern. If you have oppositely charged atoms, they are going to attract each other. That saying, opposites attract, that's kind of true when it comes to electricity, okay? If, however, you have two positive things or two negative things, if they have the same charge, then they're going to repel, okay? So these oppositely charged things are going to pull together. These negatively charged things are going to push apart. So let's predict. Let's take our positively charged field here, and we are going to drop a little tiny positively charged atom right in the middle of this field. What should happen here is this charge that we just dropped in there, is that going to move toward the center, or is it going to move away from the center? What do you think? Good for you. This charged object is going to move away from the center. And why is that? Because things, whoops, that's not what I meant to do. Things with the same charge repel, right? They push away. All right, let's do the same thing over here. Let's take our little tiny positive, we call it a test charge, actually, our little tiny positive test charge. We're going to put it right here in this negative field. What's going to happen? Is that test charge going to go toward the center, or is it going to go away from the center? Good for you. In this case, it's going to go toward the center because we know that things with opposite charges attract. Okay? All right. And those are both of our questions for today. So there are some multiple choice questions down here for the Your Turn. Please read each question and decide which of those two answers is correct. As always, if you have any questions on these notes, please write them down and we will have an opportunity to talk about those next time in class. See you next time.